All right, so we're going to prove the segments of Chords' theorem, which states that if two chords intersect in a circle, then the product of the lengths of the chord segments are equal. So essentially, if the two chords intersect in the interior, then we know the segment AB times BC is equal to DB times BE, which is right here. All right, so let's go and start this proof. So first thing is we're going to draw AE, segment AE, and segment DC, right? So let's go ahead and draw those really quick. So there we go. And then here we go. All right. So as you can see, they form these two triangles. And we're going to try to show that these two triangles are similar, okay, to get this equation. So we know by the vertical angle theorem that angle ABE is congruent to angle DBC. So at least we have this angle congruent to this angle, right? All right, well, we also know by the inscribed angle theorem, since angle A and angle D are both inscribed angles, we know that the measure of angle A is equal to half the measure of arc EC, right? And we know half the measure of arc EC is also equal to angle D, right? So this implies, of course, that angle A is congruent to angle D. So we also have that angle A is congruent to angle D. And remember, that's all we need in order to show that these two triangles are similar by the angle-angle similarity postulate, right? So we have angle A is congruent to angle D. We have angle ABE is congruent to angle DBC. So by angle-angle, this implies, so we have to make sure that the triangles line up. We know that A goes with D, so we'll have a triangle ABE will be similar to triangle. So A goes with D, D, and then the B's go together, B, C, right? All right, so now we have to form a, we have to get this equation from the similarity statement, right? So from these two triangles being similar, we know that we need AB, right? So AB goes with the other triangle on the other triangle, DB. So we know that AB over DB is equal to, and we need, what is it, BE, right? We know that BE goes with BC, right? So BE goes with BC. Now, from here, what we can do, let me go ahead and scoot this imply sign. So what we can do here is we can multiply both sides by DB times BC, right? So look at that up there. So if we multiply both sides by DB times BC, right? So DB over DB becomes 1, and we're left with AB times BC is equal to, and then we need that, we know the BC's over here turned to 1. We'll have DB times BE. And as you can see, that's exactly what we wanted, right? AB times BC is equal to DB times BE. So that is the proof.